there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and it's the first video on Core 2 integration, and we're talking about definite integrals. Now, before we begin, I want to recap the integration we've done in Core 1. It's vital that you've watched my videos on integration in Core 1 before you do this. It relies on the skills we've learnt there, and you have to be a master of those skills before you can really move on to this material. Now, I wanted to just very briefly recap what integration in Core 1 was all about. The first thing we knew about integration, well, we knew differentiation. Let's do differentiation first. We knew that if y was equal to, let's say, x cubed, we knew that we could differentiate to work out the gradient function, and we would bring down the power, keep the x, and reduce the power by 1. And we knew that was differentiation. And the first way we met integration was as the reverse process. We said to go from the thing you've differentiated, dy by dx, back to y was the process of integration. That's the first way we met it, and we met it as the reverse of differentiation. So if someone gave you, let's say if someone told you that dy by dx was equal to, let's say dy by dx was equal to 3x squared in our case, we would integrate both sides. So how we would have gone back if we didn't know automatically, we would integrate both sides with respect to x. When you integrate this, you get a y back is equal to, what we would do here is we would add 1 to the power, so we would have add 1 to the power, and we would divide by the 3 here, and we would always have a constant of integration plus c, constant of integration, and we would simplify that to y is equal to x cubed plus c. Now we would always have a constant of integration because x cubed differentiates this, but so does x cubed add 1, because the 1 just disappears on the differentiation. So we always have a constant of integration. So that's what we did in Core 1 integration. Now, there's two other things I want to mention. You don't always have to be integrating the gradient function of something. Sometimes the questions might just be integrate 3x squared plus 4x plus the square root of x with respect to x. Okay, it might just be that question there. Now, no one's told you that's a gradient function. You're not trying to work out the original function. You're just performing the integration on a given function. So just like that. So, or the other way of writing it, say if I said to you, if I told you that there is some function y and it's equal to 3x squared plus 4x plus the square root of x. And what I could do is I could ask you, what's the integral of y with respect to x? So basically I'm asking you the same question. I'm asking you to integrate 3x squared, add 4x, add the square root of x with respect to x. Now that's when the question is not, it's not in the context of starting off at a gradient function and going back to the original function. It's just perform the operation of integration on this. So just to be clear, there are two styles of questions. Sometimes they ask you, they give you dy by dx, and they say find y, and you use integration. Or sometimes they just say integrate something. I'm just giving you something, go ahead and integrate it with no relation to dy by dx or a gradient function, etc. So you've just got to be able to do this. In this case, obviously, add 1 to the power and divide, so it would be 3x cubed over 3, plus here, remember that's power of 1, and this here we would have had to write first as x to the half. Okay, so we would go, for this one here, we would say 4x cubed over x squared over 2, and this one we would add 1 to the power, so we would get x to the 3 over 2, and we would divide by 3 over 2, plus c, and we would tidy that up as x cubed plus 2x squared plus 2/3 x to the 3 over 2 plus c. And that would be the answer to the question they've asked us. Now, one last thing that this whole chapter is basically about. Do you remember I said there are two main uses for integration? Obviously, it's if you're giving the gradient function to get the original function. Now, you can just integrate something at random, but there doesn't seem real purpose to that. But sometimes in questions you're just asked to integrate. But I said there was another purpose to integration, and I said that integration can find the area of it can find the area under a curve. So say if you had a curve like something like this, the process of integration might be able to find you this area, and that's mainly what this chapter is about, the area under some curve y. Okay. Thing I would like to talk about before I do some examples is indefinite versus definite integrals, and that's the first new thing you will see in Core 2. Now, imagine I asked you to integrate, let's just say 3x to the power of 4 with respect to x. I asked you to integrate that. This here is called an indefinite integral. And I will show you why it's indefinite by basically showing you what a definite integral is, and it's the opposite of that. So that's an indefinite integral. How would you do this? Well, you would add 1 to the power, so you would keep the 3x there, you would add 1 to the power, you would divide by the 5, and you would add a constant. With an indefinite integral, you always get a constant of integration. So you always get a constant of integration. Now, here's a definite integral. A definite integral would look like this. Can you see what the difference between them is? Well, you have numbers on the top and bottom, and these are called the limits of integration. Okay, when you see this, you perform 3 stages, and here's stage 1. So stage 1, I'm going to write in blue. You do the exact same as you did before. You integrate. You add 1 to the power, so you have 3x to the power of 5 over 5. Okay? But you... okay, let's say you add the c. I'm going to change this in a second. So that would be stage 1. Okay, stage 1 in blue. Stage 2, you put square brackets around the thing you've integrated. And you put the numbers to the right hand side this time. Okay? And stage 3 is you evaluate this function at 4. So you would put in 4 in here, so you would have 3/5, and you would put 4 to the power of 5 plus c. You would put in 4 to the whole thing. Now c is just c, you can't put 4 in, so you would work that out. And you would take away the answer when you put 1 in. 3/5, 1 to the power of 5 plus c. Now, if you work this out, 3/5 to the power of 4 plus c, what do you get? 4 to the power of 5 you would get 3072 over 5 here, plus c. And here you would clearly get, take away, this would be 3/5 plus c. Now, can you see that the c, subtract the c, is going to go, and you're going to get the answer 3072 over 5, take away 3/5, which gives you the answer 3069 over 5. Now, that is what's called a definite integral. This is a definite integral. Definite integral. It has limits, and when you work it out, you always get an answer. Okay, you get an answer. And also, you never get a constant. The constant will always, when you put 4 in here, this is always a constant, nothing will go into that. And when you put 1 in, or whatever the number is, the constants will always subtract each other and go away. So really, on the first stage, when you integrated the thing, when you see definite integrals, there's no need to add a plus c here. No need at all, because they will always disappear. And we know they will disappear, so we don't bother writing them in. Like that. And we would work out the final answer. Now with a definite integral, you have limits of integration. There is 3-step process. You integrate the thing, put brackets around and put the limits to the right hand side. You put the top number in, and then you take away the answer when you put the bottom number in, and you work it out. Okay, so there are those stages. With a definite integral, you always get an answer. Indefinite integral, you will never see there what you saw in core 1, you will never see numbers here, and you always get a constant of integration. So you have to just be able to see which one's which. We're going to use definite integrals to find areas, so we're going to see much more of these now. Anyway, we're going to do some examples. Let's go straight on to some examples. Evaluate the following. Because the following, this is called an integrand, it's got a 2x here, it's an take away 3x squared plus 1. It's in the form we need, it's in powers we need, we can straight on go on and integrate. It's a definite integral because it's got the limits of integration, so we're going to do the 3-step process we talked about before. The first of those being integrate the thing. Remember, that's a power of 1. 2x, increase the power by 1 and divide by 2. Subtract. Increase this by the power of 1, so we're going to have 3x to the 3 over 2 and divide by the 3 over 2. And this here is really x to the power of 0, so we're going to get here plus x. Now we're not going to bother putting in plus c like we used to do with indefinite integrals. We're going to just forget about that now because we know it disappears. We're going to put a square bracket around this. That top number goes to the right this time now. That bottom number goes to the right this time now, like that. That's stage 1. Integrate the thing, put square brackets around, and put 4 and 1 there. Now we're going to put 4 in. Well, we're going to simplify this first. Let's simplify this because it's more complicated than it needs to be. So let's just simplify this. 2 over 2 is 1, so we have x squared. 3 divided by this here is going to be equal to 2. So this is going to be take away 2x, so 3 over 2 plus x between 4 and 1. Now we can just put in the numbers. So let's put the numbers in. Let's put 4 in first. So I'm going to put a bracket there and say this is 4 squared. Take away 2, 4 to the 3 over 2 plus 4. Subtract the answer when I put 1 in. So 1 squared, take away 2, 1 to the 3 over 2 plus 1. Okay, like that. Now we're going to work out the first one. 4 squared is 16. 4 to the 3 over 2 is equal to square root 4 to the power of 3, which is 8. So 2 times 8 is take away 16 plus 4. Take away, this is going to be 1, so 1 take away 2 is negative 1 plus 1, it's just going to be 0. So I think we're going to get the answer 4 like that. And we got an answer like we said. Now, if you've got the FX 991 ES calculator that I recommend to my students, this actually does indefinite integrals for you. You are allowed it in the exam because it doesn't do symbolic integration. And see here, you can press that button, integral. And what were we integrating? 2x, so 2 alpha x, yeah, subtract 3 alpha x to the power of a half. Come out of that, come out of that, plus 1. That was our integrand, and we were going between 1 and 4. Hit equals, and it tells you the answer's 4, and in this case you can check your answers right. Now just typing that in the exam, just typing that in and writing 4, you'll get nothing. You get all the marks for all the work in here, you'll get nothing, but it just helps you check your answer. So I'm going to keep that with us, so each time I do one I can actually check I haven't made a mistake. Let's do example 2. Again, indefinite integral. Now what you'll notice here, hopefully you'll notice, this is x to the third take away 1, all squared. So you can't integrate that as it currently is, because for integration we need some thing with x in it plus some other thing with x in it, take away something with x in it. We can't have things multiplying together. So the first thing we're going to go away and do, we're going to go and do some working. We're going to put a line there for working, and we're going to, let's expand x to the third take away 1 squared. Okay, let's expand that out and get that in the form we want. So what does this mean? This is x to the third take away 1 multiplied by x to the third take away 1. So x to the third times x to the third would be x to the third plus a third, which is x to the 2/3. X to the third multiplied by negative 1 is negative x to the third. Negative 1 multiplied this is negative x to the third. And negative 1 times negative 1 is plus 1. And we can just tidy that up to be x to the 2/3 take away 2x to the third plus 1. So instead of integrating this, we are going to transform that into the integral between negative 1 and 0, get it in the form you want before you start doing any integration. X to the 2/3 take away 2x to the third plus 1. And don't forget with respect to x. Now we're ready to try and integrate. So this is going to be the integral. Put our square brackets around. Increase that by the power of 1, so x to the 5/3 and divide by the 5/3. Take away 2x, increase that by a power of 1 and we would get to the 4/3 divided by 4/3, and increase that, be like that. We'll have no constant of integration, but we'll put a 0 there, we'll put a negative 1 there. Let's just tidy this up before we launch ahead. This is therefore going to be 3/5 x to the 5/3 take away 2 divided by 4/3. We've got ourselves 3/2, so subtract 3/2 x to the 4/3 plus x between 0 and negative 1. Now we're ready to substitute 0 in. So if I substitute 0 in here, I'm going to put 0 here, here and here. I'm just going to get 0. It's pretty easy in this case to see I'll get 0. Take away the answer when I put negative 1 in. Not as easy, so I'm going to type 3/5 negative 1 to the 5/3 take away 3/2 negative 1 to the 4/3 plus negative 1. That one's harder. Don't forget you're taking away here. I'll have to get my calculator out for this one. I'm going to take 0, subtract the answer I get for 3/5 brackets negative 1 to the 5. I want that to the 5/3. Ooh. I'll have to start this again. 3/5 negative 1 to the power of 5/3 subtract 3 over to the 4/3 plus negative 1, and get 31/10. So the answer is 31/10. Remember I typed 0, take away this, so I got the answer 31/10. Let's check our answer by using the integral facility. So what we're going to do is we're going to integrate brackets, x to the power of 1/3, take away 1 squared, between -1, 0, and sometimes it takes a little while to do it when it's a fairly complicated one, but if you just let that work through, hopefully with a bit of luck it will give us our answer. .3.1, which is, if you check, this is obviously 3.1, so we know we got the right answer there. And let's just do example 3 now. Let's just do example 3. Again, I can't integrate that currently because it's of the form like that. We want it broken up like that, so it's in things that are adding or subtracting together. So before we do any integration, we've got to just do our basic groundwork. Divide both of the terms by x squared. 2 over x squared plus root x over x squared. Now root x is x to the half. X to the half divided by x squared, that means x to the half over x squared, right? Okay, is going to be x to the half take away 2, which is x to the -3/2, which is 1/2. So we have to write this in power form before we proceed. That in power form we should know as 2x to the -2. So this is the integral between 4 and 1 of 2x to the -2 plus x to the -3/2. Remember back to our core 1 videos where before we even integrated, we did lots of work getting it split up into sums and differences, and lots of work splitting and making it written in index form before we integrate. Now we're ready to integrate. Square brackets, 2x, add 1 to the power and divide, plus x, add 1 to the power and divide. No constant, put your limits in, like that. Okay, we're going to tidy up before we substitute in. 2 divided by -1 is -2, x to the -1. 1 divided by -1/2 is -2 again, x to the -1/2. Put in 4, put in 1. If we put in 4, okay, we're going to get -2. 4 to the -1/2 is 1/4. Take away 2. 4 to the -1/2 is 4 to the -1/2 is 1 over 4 to the half, which is 1 over 2, which is just 1/2. And I'm going to put 1 in here. That's going to be -2 subtract -2, and that's going to be like that as well. So hopefully we're going to get here. I'm trying to do it all in my head to show you can do these things in your head. 2 multiplied by 1/4 is that's going to be -1/2. 2 multiplied by 1/2 is subtract 1, and this here would be subtract -4. And this here is -1/2 take away -4, which is -1/2 add 4, which is therefore equal to 2.5. Okay, so let's get the calculator out and check that that is true. So what we're going to do is we're going to integrate a fraction, 2 plus square root x over x squared, and we're going to integrate it between 1 and 4, and we get 2.5 just like we got here. Okay, and that's it for this first video on integration and definite integrals. Hope you found it useful. Thanks for watching.